Welcome back to the channel. In our last lesson, we introduced parametric equations. We use graphs to actually relate parametric equations. In this lesson, we're going to see how to convert parametric equations to Cartesian equations. We'll use the same equation we use in the graphical method. As such, so in case you missed that lesson, please do not hesitate to check the description below. I have placed a link to that lesson. That said, let's get into class. Hi, welcome back. Like I said, we're using the same equation we used last lesson, which is x is equals to t squared and y is equals to t plus 1. In case you missed that lesson, please do not hesitate to check the description below, and to ensure you don't miss our lessons, kindly hit the subscribe button. Now, in that lesson, we got this table. We were able to derive the relationship as when t was equals to minus 3 up to when t was equals to 3, and it gave us this table. Now, because we'll be making reference to this same table, that's why I've decided to keep it here. My x is equals to t squared. I'll tag that as equation 1. Now, from equation 1, I can take the square root of both sides. So that I'll be saying that the square root of x will now be equals to the square root of t squared, which is obviously equals to t. Now, look at equation 2. I'll be saying that y now is equals to t plus 1. I'll tag that as equation 2. From equation 2, I can subtract 1, or I can just move 1 to the other side. It becomes negative is equals to t. Obviously, t is equals to the square root of x, and t is equals to 1, y minus 1. So that I can conveniently conclude that my square root of x is the same thing as y minus 1. So that the square root of x, so that the square root of x now plus 1 will be the same thing as y. So that for every value of y, for every value of x, when x is equals to 9, if I take the square root of 9 plus 1, I come up with my y. My equation says the square root of x plus 1 is equals to y. I want us to start with each value of x. When x is 9, we look at when x is 4, when x is 1, when x is 0. The 1 again is repeating itself, 4 repeating itself, and 9 repeating itself. Now, when x is 9, I'll be taking the square root of 9 plus 1, which is equals to what? Y. The square root of 9 is actually the same thing as plus minus 3. Now, I'm taking it one by one so that you can have a feel of it. When it is plus 3, then my y value will be the same thing as plus 3 plus 1, which is the same thing as 4. Now, if you look at it here, this is a positive value. When it is plus 3, that's 4. Now, when it is minus 3, the y value will be the same thing as minus 3 plus 1, which is the same thing as minus 2. So you have up here minus 2. Now, when x now, let's look at it. When x is the same thing as 4, which is the next value here, when x is the same thing as 4, we're looking at the square root of 4 plus 1, which is equals to y. The square root of 4 is the same thing as plus or minus 2. So let's take when it is plus 2, we have plus 1, which is equals to y, or be equals to what? 3, which is what you have here, is 3. And when x again is the same thing as minus 2, sorry, minus 2. Y will be the same thing as minus 2 plus 1, which is the same thing as minus 1. That's what you have here, minus 1. If you continue and iterate down, you see that you get the same value on the table. Now, with this, I hope you understand how to convert parametric equations to Cartesian equation. That said, see you in our next class.